final example that we'll look at in this lesson 05 is an example of a system of inequalities with separate regions. So we don't always have to have points of intersection. Every once in a while we can end up with parallel lines that don't intersect, and we have to figure out where do our boundary lines indicate our solutions are. So what we're going to do is we're going to graph each of these lines independently. They were kind to us and they put them in slope-intercept form already. So what we have to do is just do a rough sketch of what does the line y is less than 3x minus 8 look like. So what I want to do is I want to march off 8 tick marks down below best I can. 1, 2, 3, 4, 5, 6, 7, 8. It crosses here to -8. And then we have to do a slope of 3. Well, slope of 3 is up 3, right 1. So we're going to go up 1, 2, 3, right 1. So we'll call that our tick mark for 1. Now, because our inequality symbol is just a less than symbol, what we want to guarantee is that we use our dashed ones. So just kind of repeating, these are less than or greater than, less than or equal to, greater than or equal to require the solid. So if they have a bar underneath them, they need a solid line. So I'm going to grab our dashed lines here, bring one down, try to get it to go through the best that I can. Now I need to make a determination on what side of the line do I want to be on. So what I'm going to do is I'm going to plug in my test point. The safest way for me to do this, if my line doesn't go through the origin, is to plug in the origin. So if I have 0, is 0 smaller than 3 times 0 plus 8? So is 0 less than 8? Well, 0 less than 8 is a false statement. So if I went on this side, it would be false. I don't want to go to the false. I always want to shade to the true, or make sure I go to the region that makes the statement true. So I want to be on the bottom side of that line, the less than side. The second one that we're going to do is our line y equals, or y is greater than 3x plus 4. So now I want to go up 4 units. So we'll march up 1, 2, 3, 4. Best that we can, we're up here at 4. And now our slope is identical, so that means we'll want to go up 1, 2, 3, and right 1. So in a perfect world, when I draw this line, because the slopes are identical, I know for sure that the lines are supposed to be parallel to each other. But I would need to know what side of this boundary line we want to be on, so I'm going to go and interpret what side of the line. They don't look as parallel as I hoped they would, but we'll doctor them up just a little bit. Okay, so now I'm going to put in the ordered pair is 0 greater than 3 times 0 plus 4. So is 0 greater than 4? Well, that is a false statement, which means if we went to the bottom side of that line, we'd be shading the false side. We never shade false. We always want to shade true. So that means we have to shade on the top side of the blues. This is our solution side for the blue line. When we're solving systems of equations, we want to find any places of intersection. And because these two lines are parallel, and we want to shade on the opposite sides of each of those lines, that means there's no solution here. So this one is a no solution set, which means our solution set would be empty, or there'd be a null set. So this is one of those consistent or inconsistent systems in which they don't have any solutions. Now, I've also seen them, just to prepare you for another option here, is if they were to shade both of them to the inside. So rather than being less than there, or greater than there and less than there, they might end up shading above here. Again, this is just a what if, and then below this line. So just because you have a parallel set of lines doesn't mean you may not have solutions. Then your solutions are only in here. Okay, so that's another what if. It's also possible, and I've seen these types of systems, where you graph two parallel lines, and then you're below both of them. So this one's below, and this one's below. Now what is the area they have in common, the region they have in common? It would only be the stuff that's below your green line. So those are some what ifs that you can be prepared for on your assignment.